Hey guys, hi. So in this video, we'll be looking at sequence containers, and the most primary container which we plan to start out with is vector. Right, so vector is, all of us have used vector, I believe, at some point of time. Vector is nothing, it is also known as dynamic array, as we call it. Mainly because the native implementation which vector inherits is of an array only, right? And vector is also like, it's perhaps the only container which is present in C++, which is backward compatible with its native implementation. So which basically means it is backward compatible with an array. So all the operation which can be done over array can also be done over vector as well, be it traversal, be it insertion, be it deletion, everything. Right? How do we define a vector? Vector can be defined simply just like this, wherein we have a vector here and we can keep pushing multiple elements in vector. So what are the different kind of properties which vector inherits? The first property is we can push the elements, we can delete the elements, we can traverse through all the elements which are present inside vector, we can run an iterator through it, and we can also check out the size, right? So apart from this, there are also multiple other properties as well, which we will see in later on, right? Now vector is also very important because it actually inherits one more property of array, which is contiguous memory locations, right? So all the elements which are present inside the vector are in continuity, so they will all have a contiguous memory arrangement kind of thing. So which basically states like, if we are using an integer array and this value is something like 1001 memory address, then the same thing will actually get followed up in multiple other memory chunks as well, right? So depending upon the data type what we are using here, the size will increase. Like if the data type size is x, then this memory address is going to be 1001 plus x. Similarly, this is going to be 1001 plus 2x, and will keep on growing in the similar fashion, right? So vector is contiguous in nature, and basically we can insert an element inside vector in O1 time, and we can also get any element at any given point of time in O1 time, right? So that's about vector. What are the different properties? Like basically for push, we use push underscore back. It's a function which vector has exposed. For deletion also we can use delete. For traversal we can either use normal traversal, like through a variable like I, traverse I to the size of the vector. So this can also be done. We will see in the later example while coding that how different kind of traversal can be done over vector, or it can be done through iterator. So both the traversals are easy in nature, but like depending upon the problem statement, we need to decide which kind of traversal do we need, right? Defining of vector is also very simple. We can define a vector, like if I want to define a null vector, not a null vector exactly, like a vector which is having 10 different elements and all of them are defaulted to some value. So we can define it like this, 10 comma x, where x is the default value. Right, if we want to define a 2D vector, we can also define it just like similar way. 2D vector can be defined like this, and let's suppose if 2D vector is n cross m, it's a matrix, so it will be n vector of int, which is a functor, and then m comma 0, or basically x, wherein x is the default value for all the elements which are present inside the matrix. Okay, so that's how we can define a 2D vector. Now one important property which I discussed in the earlier slide was, in vector we can actually insert as many elements as we want. So you might be thinking, if it is contiguous in nature, how can we allocate as much space as we need, right? So there are two explanations of this. The first explanation is, vector stores all the elements on heap, right? Heap is a separate memory segment which is present inside the space wherein we are running the code, and we store all the elements in heap which we are actually pushing into vector. The second explanation is, vector actually grow dynamically with increasing elements. So what does this particular thing means is, vector, whenever we keep on inserting elements into vector, vector resizes itself, it reallocates some memory, right? Now how it is happening, let's try to understand it via an example. So let us suppose like if so first of all, like vector reallocates memory in advance. So what happens is, suppose if my vector has two elements right now, okay, and the memory which is allocated to vector is also for two elements only. Now when the third element comes in, vector will obviously like reallocate memory for the third element, but it will also allocate some memory in advance, right? And how does this factor comes into picture is like it do via a factor k. Let us think, like let us suppose this factor is k, wherein it is growing the vector in every insertion. So what happens is, whenever it runs out of memory, whenever vector runs out of memory, vector resizes itself to k into current size of vector, right? So whatever the current size of vector is, it will multiply it by a factor k, and then it will resize itself. So k generally lies between 1.5 to 2. Let us, for our case, let us take k as 2 and try to understand this thing. So let's suppose I have only two elements in the vector, 1 and 2. Okay, good, happy vector is here. Now if I want to insert 3, I have to like vector needs to reallocate some memory. So what it does, it will reallocate for 4 elements. So 1, 2, 3, and this will be blank. Now next element come 4. So it will like give for this particular memory location. So we don't need to do any kind of reallocation at this point of time. Now if another element comes, let's suppose 5 is coming. So for 5, vector will again reallocate memory, and this time it will reallocate to k into 4. K is 2 in our case, so it will be 8. So vector will reallocate three like memory chunks in advance. So this 1, 2, 3, 4, 5, and these 3 will be empty. Now similarly, if 6 is coming, it will give 6 this particular position, and then 7 and 8, and after it will again resize to a size of 16. Right? So vector actually like grows itself exponentially via the factor of k, and whenever it runs out of memory, we need to basically like allocate some memory in advance. Now this thing is also known as vector resizing, and like this is one of the reasons why sometimes allocating memory in vector could be a little different, because every time we reallocate a memory, we have to move the existing elements into a new memory location. So if this is m1 and this should be m2, so whenever I am reallocating memory here, I have to copy these elements to this m2 location, right? So that's basically an overhead which we need to do. But in modern day compilers, they already have a very huge set of data which is reserved for a vector whenever you define them. So generally we don't run out of space, right? So the amortized complexity for this is over 1 only. Despite all this memory allocation and reallocation, the complexity which comes out for inserting an element into a vector is over 1 only. This is insertion complexity. Just keep this thing in mind, this is how the vector reallocates itself and reallocates the memory, right? Now another thing which we plan to discuss is pair. Okay, so pair, most of the people think of pair as a container, but generally pair is not a container at all. Okay, pair is just a tuple of values. What do I mean by this? Like think of a pair like this. That's it. So pair is more like a data type wherein we have two different values. It could be key value pair, it could be a normal tuple, it could be anything. But pair is more like a data type which we use, more like data type only. It's not a container. Okay, now if I want to define a vector of pair, what I can do, I can just define it like this. Vector of pair int comma int, and that's it. Now if I want to insert an element, I have to insert like this, v dot pushback. And although there are multiple ways we can insert, we'll see in the coding example of like coming just now, but this is how we can insert. This is the most primary way we can insert elements into a vector of pair, right? One important observation here is in pair, like pairs, if we want to compare two different pair elements, they will be compared from left to right. So if I have two different elements, let's suppose 3 and 6, and then I have 3 and 7 in a pair. first of all, pair, like when we are sorting them or when we are ordering them, it will compare the first element, right? If the first elements are equal, then it move on to the second element. It will check, okay, 6 is lesser than 7, so 3 6 will come first and 3 7 will come later, right? So this ordering gets followed up in pair automatically, and whenever we are sorting a vector, like if we sort out this vector, the sorted result will be in this order only. Like first of all, the preference will be given to the first element, and then the secondary preference will be given to the second element, right? So that's about vector. Let's look at the coding example now. So the first thing which you need to do is to define the library, right? So as I told you, for every particular container we need a different library, but in this case we can use an universal library which will help out in most of the container, which is standard bit/standard C++.h, right? The second thing is to use the namespace. So the default namespace which we use is std, and it is the one which contains all the code, all the libraries and classes, objects of multiple containers, right? Let me define the main function now. So we will just create a template. So this is my boilerplate. Now namespace, as I told you, we can define a custom namespace as well. So let us first of all try to define a custom namespace. So if I try to create a namespace here, let's suppose I create my space, and inside my space let me define a variable. Okay, so this is the namespace, the custom namespace which I am defining. So inside this, let us try to access this namespace in the main function. So how we can access it? We need to give the name colon and the name of the variable. So we can just make it cout. Let's try to print this variable here. So this will help me print. Let us try to run this code. Great. So this is how we can define a custom namespace, and this is exactly how the std is actually defined. So std is the global namespace in C++, and when we import this particular library, we will import the standard namespace as well. So it is all the functions, all the objects, all the classes are defined inside this std namespace, right? Now let us look at the other thing, which is the vector which we want to define. So the definition of vector follows something like this. We can actually define it like this as well, or if you want to create some few elements and initialize them with a value, let's suppose some value, we can define it like this, right? But let's just go with the trivial implementation only. So inserting element will be pushback, so we can actually insert few elements here. So let me define just, and now comes the iteration, right? So the iteration part of vector can be done in two ways. We can either do it just like the native array implementation. So we define a variable which will run through the size of the vector, right? Or take up all the elements, and we can do v of I, it will print all the values. So this is basically the array based iteration. The other kind of iteration which we can do here is through the iterator itself, right? So we can define an iterator something like this, and inside this iterator I will just pass this like so. And let me just run through the iterator v dot begin and not equal to v dot end, and increment the iterator here. So this will actually keep incrementing the iterator, and since iterator itself is a pointer, as I told you, so for dereferencing we need to use the star. So this will also print all the values of the vector. Okay, now we don't need to define the iterator all the times just like this. There is also an auto keyword inside C++14 which we can use. So what it does, it is basically, if I just comment this portion out and I define it like this, so this will also work because we are defining an auto iterator, so it will automatically fetch what kind of iterator we want to use, right? So that's another way of iterating through the values. The third way which we plan to discuss, let me just write down here. So this is the second way of iterating through the vector. This was the first way, the array based iteration, and the third way we can define it is the general one, wherein we'll keep popping the elements from the vector and keep printing them. So what we can do is we can just do while my vector is empty, while my vector is not empty, I'll just keep popping elements. First I'll just print the elements. So v dot back, this will give me the last element from the end, and I will do b dot pop back. So this will actually pop from the back. So this can also be worked out. Let us see if it is giving me the result. Yes. So if you see, we have 5, 10, and this is actually returning the values, right? So that's how we can define the vectors. There are multiple ways. Now let us see what a pair can do, right? So pair is, as I told you, it's just like another data type which you can use. Now defining the pair, like pair should always be combined with a particular container. So use that container as vector. So if we try to use this as a vector here, let us see if we can define a pair of a vector of a pair. So defining a pair of vector would result something like this and give me another vector. Right, now I can insert the values. So there are two ways we can insert the values inside a vector of pair. First one is to v dot push back and then do make underscore pair and then give the values. So let's suppose if I give 2, 1, 2, 3, or the other way, which is the easier way, is to just define it like this. So 4, 5. And similarly, now we can iterate through the vector here. We can use the auto iterator. And this will actually keep on incrementing, and I'll print the values, right? Now to print the values, we can use this operator wherein it will print the first value and then a space, and then we will print the second value. Okay, so let's try to run this now if it is working. Okay, we are getting some error. Okay, this has been defined twice. I think that's the error. Let's just try to comment this part. Okay, I think I used the typo here. Okay, so this will also print the values of the pair. So vectors are very compatible with other data types. We can actually use another all kind of data types. Like we can also define a vector of string and make use of it, right? So here we can actually insert string inside this vector. We can also do vector of character, vector of float, different types of vector, right? So that's how we can define a vector, and there are 3 ways we can traverse through them. And then there is a pair with the vector. There is also one more thing, which is a 2D vector. So defining a 2D vector could be done something like this. So if I define it vector of vector, so this will help me define the 2D vector, right? Now if you want to define a 2D vector with all values 0, let's suppose if I want to define a vector of n cross m, then what we can do is we can actually give those values here. So n comma vector int and then define the value m comma 0. So this will actually initialize a 2D vector with 0 values. 2D vector of size n cross m with all values 0, right? Similar way we can define a 1D vector as well, just like I told you earlier. V of, let's suppose n values are present, we can define it like this. This will create an empty vector for us with n elements, all of which are defaulted to 0. Sure. So that's about vector in this session. Thanks.